Redox reactions, an AP chemistry tutorial. Let's look at redox basics. In an oxidation reduction reaction, typically a metal reacts with oxygen. In this particular case, if you have oxidation, you're losing electrons. Think Leo. Reduction is occurring meanwhile, for this particular case, with oxygen gas when it gains electrons from calcium. Think of Gur, gain electron, reduction. Leo the lion goes Gur. These occur together. For oxidation numbers, we assign every species a value to keep track of the transfer of these electrons. These numbers are called oxidation numbers. There are various rules for assigning oxidation numbers. Please study this and make sure that you understand and know all the rules. Here is an example, or two examples, of problems that you might see. For the first one, you have to identify the oxidation number for bromine within this compound. To figure it out, you would look at oxygen, and it follows the rule that its typical number would be -2, and there are 4 of them, so that's a total of -8. Meanwhile, hydrogen has a charge of +1. That would make the bromine have a +7 charge. In the second problem, we would have to look at N2 and H2 as both having 0 charges, as they are elemental as reactants. However, when hydrogen goes to form ammonia, a 1+ hydrogen is formed. So going from 0 to 1+ is getting more positive, which means it's getting oxidized. Whereas the nitrogen, going from 0 to 3-, since it's going down the number line, it's getting reduced. The rest of this video treats balancing more difficult redox equations using the half-reaction method. There are 3 basic steps. 1, you have to split up the oxidation reaction from the reduction reaction. Number 2, you then balance these half reactions separately. And finally, number 3, combine them to get the overall reaction. You might recall a titration experiment. In the titration experiment, the endpoint was reached when we were able to get the equal ratio of the coefficients of, say, permanganate to oxalate, as an example. But what is that mole ratio? You have to find that by balancing the redox equation, which is a little different from balancing typical equations, as we have to balance the electrons being transferred. How do we do this? Step 1, take a look at the overall equation and assign charges. Once you assign the charges, you can then recognize which species in the reactant side is being reduced. In this case, permanganate is going from, the manganese in permanganate is going from +7 to +2. So it's being reduced. Then you have to recognize that the carbon in oxalate is going up the number line, so it's losing electrons or getting oxidized when it forms carbon dioxide. So by recognizing that the manganese go together from beginning to end as one half reaction, and the oxalate has the carbon in it that converts to CO2 as the other half reaction, you can continue on in looking at each individual half reaction. So let's look at the oxidation half reaction with the carbon in it. First, we balance the carbon. So we add a coefficient of 2 in front of the carbon dioxide. Then we notice that the oxygen is balanced, but we notice that the charge is not balanced. So the charge must equal on both sides, and so to do that, we're going to add 2 electrons to the right-hand side. Now we go to the other half reaction, the reduction reaction. The manganese is balanced, however, the oxygens need to be balanced, and you balance oxygens on the opposite side with water. However, now you have 8 hydrogens that you need to balance out by using protons on the left-hand side. Again, to balance the charge, we're going to need to add 5 electrons to the left side, and in doing so, we end up with a net +2 charge on both sides. Now we can look at the 2 half reactions and note that the top reaction needs to be multiplied by 5 all the way through so that the electrons will cancel out. Looking at these top 2 equations, you can see that the reaction has reached what we call its endpoint when we're titrating, or we can see that the equation is being balanced because the electrons are actually completely transferred. So the electrons cancel out. There is some simplification, and you can see that when we reduce everything, we are left with this equation here.